All right, welcome to warm-up number 10. Okay, we're going to use the law of detachment here. So the law of detachment says if you've got a conditional statement, this is an if-then. If P happens, then Q happens. And let's say you know that P happens, well, you know what's going to happen. Q is going to happen next, right? So you can make the new conclusion then that Q is going to happen. So if x equals 3, then y equals 4. Well, hey, x equaling 3 leads to y equaling 4. So I know that, hey, x equals 3. I know what's going to happen. Y is going to equal 4. That is the law of detachment in action, okay? Next example, x equaling 5 leads to y equaling 6. Where does y equaling 6 lead to? Some people are going to say, oh, x equals 5, but they are incorrect. Maybe that's true, but I don't know that that's true. I don't know where y equaling 6 leads to. This is a question mark, okay? So x equaling 5 leads to this, but that doesn't mean it works in reverse, right? The if then has a direction. Starts at x equaling 5, ends at y equaling 6. So y equaling 6, I don't know where that leads, so I can't use the law of conclusion here because they gave me the conclusion, right? If you look at the law, P leads to Q, and then you have P here, but in this example, they gave me Q here. I don't know where Q leads. I know P leads to Q, but I don't know where Q leads. So this is going to be not possible. Okay, or no solution or something like that. Okay, so we're going to do an algebraic proof here. This is a two-column proof, two-column proofs. Hey, here's my two columns, okay? This left column is statements, the right column is justification. So this is a math problem, really, right? So we've got this equation here, and if we go all the way to the bottom, B is isolated. So let's say, I gave you this and said solve for B. These might be the steps that you would use. So someone's already done the actual math here. We just have to justify, kind of follow their thinking, figure out what's happening from step to step. So I'm just going to go through these step by step. So step A, well, nothing's happened yet. This is just a math problem written down, right? So someone just made that up. This is given. The first justification for any two-column proof is always given. You got to start with something. They have to give you a diagram or some information or something to start from, okay? So then we're going to see, well, how does this equation change from step to step? I'm thinking, how did I get from step A to step B? Well, I can see on the left, okay, that 2 is now a 4. So you could say, oh, well, what if we added 2c squared? That would work. But then if you look on the right, that didn't happen. So adding is not going to work. But if I look at all three parts, hey, this is also doubled, right? And if I multiply this by 2, I'd get 4bc. And if I multiply this fraction by 2, the 2's would cancel. So the whole equation has doubled from step A to B. So that means we've taken both sides of the equation and multiplied. So this is the multiplication property of equality. Now you're welcome to write out that whole thing if you like, but that's what I'm going to do. Multiplication property of equality. You should really put the equal in there to show that it's a property of equality because we've got different types of properties. Okay? All right, so next step, I'm thinking, okay, well, how do I get from this to that? Well, I can see, okay, the square is gone. Some people might think, oh, I took the square root, but no, you didn't because the square root of 4 would be 2. So we're not taking the square roots, but notice, hey, the c's missing there and the c's missing. So I could achieve that by dividing everything by c, right? I could do this to the whole equation. I'd be dividing the entire equation by c, and that means I'm using the division property of equality. Okay? All right, let's look at the next one. And then, oh, the a moved, right? The a moved to the other side. So you could achieve that and by subtracting a from both sides of an equation. Anytime you do something to both sides of an equation, it's going to be a property of equality. Here we're subtracting, and so this is the subtraction property of equality. And if you just write sub, it could be substitution, right? Substitution or subtraction, I can't tell. So if you're abbreviating, get far enough so that we can tell that this is subtraction, not substitution. This is the subtraction property of equality. Okay, next up. So now I'm looking, okay, well, D and E, the equations are very similar. Just the equation has flipped around, okay? And when you take an equation and you just flip it over the equal sign, that's called the symmetric property of equality. Okay, it gets confused with reflexive. I find that those get mixed up. Reflexive is when something equals itself. Symmetric is when you can take an equation and flip it around, okay? And then our last step, let's see, well, hey, we've got a fraction all of a sudden. We've got a 4 down there. And also, hey, this 4 has disappeared. So we can achieve that by dividing the whole equation by 4, right? If I did that, the 4's would cancel, and that gets me to step F. So then I'm using the division property of equality once more, and I've completed the justifications. Okay, and that is it.